Hi! At last we are at the final video in our series on the naming of the organic compounds as required by the CAPS document for physical science in grade 12. This material is been set together in collaboration with educators of the Eden and Central Karoo Education District. They're not perfect, we are still working on them, so if there's anything that you would like to add or any mistakes that you spot in these videos, please contact us at the district office in George and we will gladly update to give you a better product. We are busy naming the organic compounds and we said that we're going to do it from back to front. So in our first 4 videos, we looked at exactly how we identify the homologous series. Then in our next video, we looked at, in the video 5, at how to identify the position of the functional group. In video 6, we paid attention to the number of carbons that we will find in a carbon chain. And then in the next video, we made a special small little video on how to name the ester specifically. In this video, we are finally focusing on the front part of the name, which actually indicates all the side chains connected to the main carbon chain in an organic compound. Now, what do I mean with a main carbon chain and so on? If I look at this organic compound, can you see there's a carbon there attached to these series of carbons? There's I find a carbon chain and there's something else as well. So in this one, I have one long carbon chain to which there is several side chains connected. Let me mark them for you that you identify them quite nicely. Okay, we start from the back. So we see initially that we have only single bonds, but somewhere there's an OH group attached. So we know that in this organic compound will end with OL because we have the functional group, which is an alcohol. The second thing that we notice is that is our main long chain. That is the carbon chain that consists of the most carbons. Now, what do I mean by a carbon chain? A carbon chain is just a series where one carbon is connected to the other. We have more than one carbon chain in this example. Let me show you. In this one over here, I've got 1, 2, 3, 4, 5, 6, 7 carbons. But I can also start over here and have 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. A carbon chain will be any series of carbons where there are just a carbon connected to another carbon, and so on. So from the previous knowledge that I have, I know this functional group or this organic compound is going to end with ol because the functional group is an alcohol. Then I also know if I have identified my carbon chain, I need to number it in such a way that the functional group is on the lowest possible carbon. If I number it according to the blue numbering system, you will see that the functional group is on the last carbon. You will also see that in this carbon chain, I have 7 carbons, which means the name that I will have up till now will be heptan 1-ol. All showing me the homologous series, 1 showing me the position of the functional group, and the heptan showing me how many carbons I can find in the longest chain. But to this longest chain, there can also be connected some side chains. And now I need to mark them and identify them. When a side chain consists of carbons, like this one and this one, it will end in -il. In this compound, I can see there's a methyl. Where does the me come from? There's only one carbon attached and an ethyl. So in my name, I will have a methyl and ethyl. Again, they can be attached to any of the carbons, so I specifically have to use a number to indicate on which carbon there is. Now I already numbered my carbon chain, so I see that my methyl will be on the 6th carbon, so I will have 6 methyl, and my ethyl is connected to the 3rd carbon, so it will be 3 ethyl. In my name, my side chains are placed in alphabetical order. Since E is before M in the alphabet, in my name I will first have my 3-ethyl and then my 6-methyl. So the complete name for this compound will be 3-ethyl, because E becomes before M, 6-methyl, heptane showing me the 7, 1 showing me the position of the functional group, and all indicating the homologous series. When there's more than one type of side chain, I number it as follows. Let's look at this example. First, I want to determine the homologous series. I see there's only single bond, so I know I have an alkane, and it's going to end with ane. I identify my longest chain. There we have it. The 7 carbons going to this side. How do I number this? In this case, this compound is symmetrical. What does it mean? What do I mean with symmetrical? Whether I number it from this side or that side, my first side chain will in both cases be on carbon number 3. Can you see if I go from this side, then there I've got a carbon attached to the 3rd one. If I started over here, 1, 2, 3, there I will also have a carbon connected. So in this case, it doesn't really matter whether I number from this side or that side. But anyway, I've numbered my longest chain. It's an alkane, so I don't have to put in the position of the functional group, so I'm not going to have a position there. It's going to be a heptane because I'm working with 7 carbons in the main chain. And now I have to name my side substitutes. I've got 2 side chains, this one over here and that one over here. Both of them contains only 1 carbon, so both of them will be a methyl, but I've got 2 of them. So I'm going to indicate it using the prefix di. If I have 2 side chains that is similar, I use di. If I have 3, I use the prefix tri. So in this case, it's going to be dimethyl. If it were 3, then I would use trimethyl, and if it were 4, I would use tetramethyl. But anyway, let's look at this one first. I've got 2 methyls, so it's dimethyl, and I need to indicate the position of both of them. So in this case, it will be, this one is on number 3, and that one is on number 5. So my name for this organic compound will be 3,5-dimethyl heptane. There's a few things that you should look out for when you're working with organic compounds. In the first place, your longest chain will not always be the horizontal one running across. Look at this example over here. If I look at this carbon chain, it seems like this chain over here consists of 1, 2, 3 carbons. But that's not the longest one. If I look at this chain that's running down here, it consists of 1, 2, 3, 4 carbons. So that will actually be my longest chain that I'm going to use to name this carbon. Let's quickly see if we are able to name this. I look at the homologous series. See, I only have single bonds, so I know it's an alkane, end with ane. Do not have to indicate the position of the functional group because it's an alkane. I see in my longest chain that I've got 4 carbons. That's what the bute comes from. And then I see I've got 2 side chains, again 2 of the same, both of them contain 1 carbon, so it's 2 methyl groups, so I'm going to call that dimethyl. And in this case, both of them are situated on the same carbon. And remember, I must number my carbons in such a way that the side chains, if there's no functional group, then I look at the side chains, are on the smallest possible number. In this case, both of them are on number 2, so I write number 2 twice. If there's a dimethyl before the di, there must be 2 numbers because I need to indicate the position of 2 methyls. If it was trimethyl, there must be 3 numbers in front here. Oh, I made a small mistake here, which I'm going to look at later on, but let me just quickly correct that. There, I've corrected my mistake. That's much better. When I write down the name of any organic compound, I always separate numbers with a colon and numbers and letters I separate with a hyphen. I forgot the hyphen previously. We haven't really touched on that. That will be done in our very, very last video when we look at the theory that surrounds organic chemistry. Another thing that we must look at is your longest carbon chain is not necessarily in a straight line. Let's look at this example. It appears as if this should be my carbon chain, but in fact, if I look at it carefully, can you see that all of these form one long chain? This is an alkane, only single bonds, so I can see that the longest chain consists of 1, 2, 3, 4, 5, 6, 7, 8 carbons. So the name for this organic compound is then octane. There, as I suggested earlier, when you write the name of an organic compound, always remember that your numbers are separated with a comma, and the numbers and letters or numbers and words are separated with a hyphen. Okay. I think you are now ready to try and name the organic compound. So please try the following exercise. In this exercise, the exercise or the answers will be marked wrong if you make any spelling mistakes or put in any extra spaces, simply because the program is set up in that way. So be very, very careful. Remember, you can do these exercises more than once. Good luck!